Hello, I'm going to go through and answer some of the questions on the answer key. I've posted a PDF of the answer key as well that you can look at, but this way you can kind of go through and see the process as I'm doing it, right? So when we are given questions like this, where you're given a measurement or a quantity and it has units associated with it, and you're converting it to different units, right? We're going to use this table, these kind of prefixes that come out of it, right? The one thing that's not on here is that our base unit, right? This is the SI unit, right? So this could be grams or meters or seconds or whatever. That's here, and the conversion factor for the base unit is 1, right? So when I look at this first question, for example, I have centimeters on this side, I have meters on this side. And so what I want to do is I want to kind of, what are the factors that I'm using for these units? Centimeters is the meters, the base unit. Centi is that's what the C represents. And so the factor that I'm using there is 10 to the negative 2, right? That's the factor in our table. Meters on the other side is the base unit, and so the factor there is 1. So now to convert this, what I'm going to do is I'm going to take my magnitude, right, the number that I started with, 67.46. I'm going to multiply it by the factor that it begins at, 10 to the negative 2, and I'm going to divide it by the factor on the other side, 1, right? Now, I also need to put in the units here, so this is going to be centimeters, and then I'm going to have meters per centimeter on the other side, right? The nice thing about this is that what I'm doing is I'm setting up the cancellation of centimeters, right? I'm putting centimeters on the bottom. So I have centimeters on the top, centimeters on the bottom. What this does is because I have the factors set up here, this factor on the left side will always go on the top. This factor on the right side will always go on the bottom. That will automatically set me up to have a nice conversion that will work. Centimeters cancel. I end up with 67.46 times 10 to the negative 2 meters, right? So then I just need to do that calculation, right? So 67.46 times 10 to the negative 2 moves the decimal place 2 places to the left, and my final answer is 0.6746 meters. Okay? So this is how we do this across. We're going to see that this is consistently what happens, right? Microliters. The factor of micro is 10 to the negative 6th. And then we have nanoliters over here on this side. The factor of nanoliters is 10 to the negative 9th. And so to get our answer, we're going to take our magnitude, 0.451 microliters, times the factor where we started, 10 to the negative 6th, over the factor that we're converting to, 10 to the negative 9th, right? And then I want to get my units here, so this is going to be nanoliters per microliter, right? I always want to put nanoliters at the top in this case because that's what I'm converting to. I want to put microliters on the bottom because that's what I'm converting to, right? So this will always get us the right factors in the right position, and so we get microliters canceling out. And what we end up with is, I haven't left myself enough space, but we'll just keep going here. 0.451 times 10, oh, it just put me off there. Okay, times 10 to the negative 3rd nanoliters, right? And 10 to the negative 3rd is a condensing of 10 to the negative 6 over 10 to the negative 9th, right? When that all gets divided out, that should be a positive 3rd, sorry. 10 to the positive 3rd. Right, so 0.451 times 10 to the 3rd nanoliters. 10 to the 3rd means I move the decimal point 3 places to the right, and the final answer is 451 nanoliters, right? So when I take 10 to the negative 6 divided by 10 to the negative 9th, the answer is 10 to the 3rd I multiply that by 0.451, and I get my final answer. Okay. You can always double check these things. If you're going centimeters to base unit, you're moving down the table, right? We started at centa and we went to the base unit. That means that my answer is smaller, right? We have a larger unit. Meters are larger than centimeters, which means we're going to have fewer of them. So if I start at centimeters and move to meters, the answer will always be smaller, right? So you can always double check this. If you know what direction you're moving, if I'm going micro to nano, I'm moving in the opposite direction, right? I'm starting with microliters. My answer is in nanoliters. That means I'm moving up this table. That means the answer should be larger. Right? So because of the direction I'm moving, microliters to nanoliters, I know that 0.451 versus 451, my answer is larger in the same way that I want. Okay? So this is the strategy. Use the factors that each unit represents, each prefix represents, 10 to the negative 2, 1, 10 to the negative 6, 10 to the negative 9th. When you do your conversion, you take your initial magnitude times the factor of the unit you started with, divided by the factor of the unit you're converting to. So in this case, 10 to the negative 6 is where I start, 10 to the negative 9th is where I'm going. So I multiply by 10 to the negative 6th, I divide by 10 to the negative 9th, and that gives me my final answer. Okay. All right, so now at this point, I would encourage you to pause the video, try the other two that are there. I'm going to keep going because here I am, right? And me pausing just ends up being dead audio space. Once again, in this case, ignore all the magnitude stuff over here. All we're looking at is what is our unit. I've got grams and I've got micrograms. So grams is our base unit. So grams has a factor of 1. Micrograms, we just did micro, so we know that the factor is 10 to the negative 6th. Right? Once you know those factors, then you're just plugging that into the same situation that we had before, right? 5.2 times 10 to the negative 3 grams times the unit, the factor that we started with, 1, over the factor that we're moving to, 10 to the negative 6th, right? And then this is going to be micrograms per gram. All right, so then when we multiply all of this out, the grams are going to cancel out. 10 to the negative 3rd over 10 to the negative 6th is going to equal 10 to the positive 3rd. And so what you get is 5.2 times 10 to the 3rd micrograms. Once again, we're going from the base unit to micro. So our arrow is going up. We would expect our answer to be larger than our starting point. And in fact, that's what we get. We get 5,200 micrograms. One more time. Start with units. We've got meters, we've got kilometers. The meters in this case are the base unit, so the factor is 1. Kilometers, the factor is 10 to the 3rd, right? Notice that this time we're moving down. We're going from meters to kilometers. So before I even start, I know that my answer is going to be smaller than my starting number. Okay, but now we put it into the whole problem. 9 point, I've already messed this up. 9 point, come on, give me a pen. There we go. 892 times 10 to the negative 2 meters times starting factor 1, and then the factor that I'm converting to, 10 to the 3rd. And then my units, I switch it around. The unit I'm converting to over the unit that I started with. All right, multiply these out. Meters go away. And what we get is, I'm only going to do the tens here because I'm going to leave my 9.892 the same. When I have 10 to the negative 2 divided by 10 to the 3rd, right? When I divide by 10 to some power, if I have the same number and they have different powers, this expression, 10 to the negative 2 over 10 to the third, is equal to 10 to the negative 2 minus 3, right? So you subtract the denominator power there, and that gives me 9.892 times 10 to the negative 2 minus 3, and that's going to give me, of course, that equals 9.892 times 10 to the negative 5, right? So that's how I kept getting my 10 to the third power in these other ones, right? 10 to the negative 6 minus negative 9 is 10 to the positive 3. 10 to the negative 3 minus negative 6 is 10 to the positive 3. Right? Now, in this case, I don't need to move the decimal point. I have 9.892 times 10 to the negative fifth, so I can just fill that in here. 9.892 times 10 to the negative fifth. Right? So once again, this number is smaller than the number that we started with because we're multiplying by a much smaller factor of 10. 10 to the negative fifth is much smaller than 10 to the negative 2, and so that checks out. All right, so that's these 4 answers, right? We go, in the first one, we went smaller because we're going centimeters to meters. In the second one, we went bigger, microliters to nanoliters. Third one, bigger again, grams to micrograms. Last one, meters to kilometers, our numbers got smaller. In every case, the strategy is the same though. You start with your magnitude and you multiply it by the scaling factor of the starting unit divided by the scaling factor of the ending unit, and then it's ending unit over starting unit as the units. That allows you to cancel stuff out. You get the right, I left off my units here, you guys, right? You get the right units for the whole thing. So now I fixed it and no one will ever know. Okay, I'm going to do the second half in another video. I'll see you there shortly.